Okay, so moving on to October 2010 paper 6-1. So October 2010 6-1. Okay, this is question number 4 over here. Okay, pegs are to be placed in 4 holes shown, 1 in each hole. The pegs come in different colors and the pegs of the same color are identical. Okay. Calculate how many different arrangements of the colored pegs in the 4 holes can be made using 6 pegs, all of different colors. Now this is easy because we have 6 big pegs and we need to arrange them in 4 slots. So this is just 6p4 or 6 times by 5 times by 4 times by 3. Because for the first lot we have 6 choices, for the second we have 5 choices, for the third we have 4 choices, and for the last one we have 3 choices. So 6p4, that is equal to 360. Right, okay. Now part 2. 4 pegs consisting of 2 blue pegs, 1 orange peg, and 1 yellow peg. So we have now 4 pegs now to choose from, and 2 of them are duplicate. So this is very easy because we have now 4 pegs to choose from. So 4 factorial, and 2 of them are duplicate. So 4 factorial divided by 2. This goes to 12. Right, okay. A barrel has 12 pegs consisting of 2 red, 2 blue, 2 green, 2 orange, 2 yellow, 2 black. Okay. Calculate how many different arrangements of the colored pegs in 4 holes barrel can make using 4 different colors. Right, okay. Now we have 4 different colors. So we're still choosing, but we're arranging our selections also. So we have 2 blue, 2 red, 2 green, 2 orange, 2 yellow, 2 black of those, right? But we can just have 4 different colors, not all of them, just 4 different colors. So what we will do over here, for each one of them, we will have 1, 2, 3, 4. Now I have how many different colors? 1, 2, 3, 4, 5, 6. So I have 6 colors, and I can only choose 4 out of those 6. 4 out of 6. And I can only choose one of them. So, right? So this is like 6. Again, I have 6 colors to choose from, and I can only get 4 colors. And I need to arrange them. So this is like 6p4. Same thing. Same thing as over here, that will be 360 also. Another way we can see this, since we're selecting 6 colors out of 4, 4 colors out of 6, and we're arranging them differently, so we can also write it like 6c4. Out of 6 colors, we're selecting 4 colors, and we are arranging them 4 factorial ways. So mathematically, this is equivalent, and we will still get 360. Okay. Now we need calculate how many different arrangements of the colored pegs that the 4 hole barrel can make using 3 different colors. Now before we had 4 different colors, now we need 3 different colors, right? So now we have a complication over here because 3 different colors means 2 will be duplicate. 2 pegs will be duplicate at least. So we need to come up with different scenarios with what we can get, right? So maybe we get 2 red uh, and the other one anything, right? Now, if there are 2 red, the rest of them could be anything. The rest of the 2 could be anything from any other color, but not 2 at the same time. So we can only select one of them. So how we can actually do this, since we're still arranging them, we still have 4 factorial for all of them, right? So we can go with using the selection route, also combination formula also, and the permutation way also. So let's see how we can do this. We need 3 different colors, right? So for each one of them, I have 1, 2, 3, 4, 5, 6 colors. But for each one of them, I have how many? Uh, 4 slots to fill. So for example, I get 2 red over here. So how do I do this? That means if I get 2 red, I have to select the other 2 now, right? So this means that the other 1, 2, other 6, from the other 6, I have to choose from the other 6 now. If the 2 reds are chosen, whether or not I have already done that, so 4 factorial times by the other 4, 6 C 2. So 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5. So from 6 other colors, so 1, 2, 3, 4, 5, sorry, 5 other colors. So sorry, 5 other colors. I have to select for each one 2. And 4 factorial, we will also divide by 2 because we will have identical colors also. And this will carry on how many times? For blue, green, orange, yellow, and black. So 1, 2, 3, 4, 5, 6. So this goes like 6 times. 5C2 times by 6 times. Right? So let's calculate the value. So 4 factorial divided by 2 times by 5C2 times by 6. We get 720. Okay. All right. Any of her 12 pegs. Now we need to make we need to arrange 4 pegs, but from any one of those 12 pegs. Any of her 12 pegs. Now this means that we can have how many choices? We can have different colors also. We can have 3 different colors also. We can have how many different colors possible we can have? We can have all different colors also, 4 different colors. We can have 3 different colors also. We can have 2 different colors also. But we cannot have one single color, right? Because we do not have 4 of any one of them. So for all different, we have already found out to be, in part 3, we did 360. 3 different colors we have found for 720. And for 2, now we need to find two same colors now. Now we have 2 same colors. So again, 4 factorial divided by 2 factorial, because we have, for example, let's take green, green, yellow, yellow, for example. So 4 factorial divided by 2 factorial divided by 2 factorial. And this will be the case how many times? We have how many choices of different colors? 1, 2, 3, 4, 5, 6. 6 choices for different colors over here. And we can only choose how many times? 6C2. So 6C2 times by 4 factorial divided by 2 factorial. 2 factorial is 4, basically. That is 90. This is 90. So finally, we just add them all up for any case. 360 plus 720 plus 90. So plus 360 plus 720. We get 1170. Right? Just as a recap, to get any of our 12 pegs, we can have different scenarios. We can have all different colors. We can have 3 different colors. We can have 2 different colors. We cannot have one single color because we do not have 4 of any of those colors. So we have found for the number of arrangements we can get for all different colors, number of arrangements for 3 different colors, we needed to find for 2 different colors, and then we add them all up into one final number. Right, okay. That's this question. Moving on to the October 10 variance x2, question number 5. This is question number 5 in my worksheet. I made this for the purpose of this video. You will have to find out what question it is in the exact past paper. A committee of 6 people, which must contain at least 4 men and at least 1 woman, is to be chosen from 10 men and 9 women. Is to be chosen. That's a key word over here. Find the number of possible committees that can be chosen. Right? Now, at least 4 men. So we have 6 places, 1, 2, 3, 4, and 5, 6. At least 4 men and 1 woman, right? So that means we can have 4 men, we can have 5 men, right? So if we have 4 men, we will have 2 women, and if we have 5 men, we have 1 woman. This is the criteria. This is the minimum criteria over here. We cannot have other cases over here. So because we need at least more than at least 4, that means 4, 5. If we do the 6 men, we will let go of the women over here. Okay. So if you need to understand the total possibilities that we can have, 0 men. So if we draw sort of like a table over here for men and women, we could have 0 men. The women will be the opposite, obviously. If we have 0 men, we can have how many women? 6 women. 1 man, 5 women, 2 men, 4 women, 3 men, 3 women, 4 men, 2 women, 5 men, 1 woman, and we have 6 men, 0 women. Okay, so we are only concerned with at least 4 men, 4, 5, and greater than 1 woman. So greater than 1 woman. So this and this. So when we intersect these, we get this scenario here. Okay, find the number of possible committees now. What we'll just simply do is we have from 10 men, we need to select 4 men, and from 9 women we need to select 2 women. For the second one over here, we have from 10C5 times by 9C1. So we add these together. So 10C4 times by 9C2, 7560, 10C5, 9C1, 2268. Okay, so we add them together, 7560, we get 9828. So this is the part 1 over here. Second part. Find the probability that one particular man, Albert, and one particular woman, Tracy, are both on the committee. Now, what does this mean? This means that Albert and Tracy are on the committee, and we have to select 1, 2, 3, 4, 4 more people, right? And we still have to follow this criteria over here. So 4 total men, 2 women, or 5 men and 1 woman. Okay, so this is what we have to do over here. Now, for the 4 cases over here, when we need 4 men and 2 women, right? One out, so one Albert, so one of them are already gone. So that means we need to choose 3 men and 1 more woman. So this means that out of 9 men, we need to select 3 more men, and out of 8 women, we need to select 1 more woman. Similarly, for 5 men and 1 woman case, that means we need to select 4 more men and 0 women, because 1 woman has already been selected. So 9C4 times by 8C0, right? So these are the total possibilities that we can make. So 9C3, so I have 9C3 times by 8C1, I get 672, and then I have 9C4 and 8C0, I get 126. So 126 plus 672, I get 798. Right? So the total number of committees that could be formed were 9,828. But for the probability that Albert and Tracy are already being selected, so the probability, the case would be this 792 divided by 9,828. So 98 over here. 98. 798 divided by 9828. That is 19 over 234. Right, moving on. Find the number of possible committees that include either Albert or Tracy, but not both. Okay, so now again, we have a complication over here. So now if we include Albert, so if Albert on the team, this means that Tracy cannot be there. So that means I have Albert, so 1, 2, 3, 4, 5 less, right? If I have already chosen Albert, but I cannot select Tracy. So this means that I don't have 9 women to choose from, I have 8 women to choose from, right? And if Albert has been chosen, also again, we have 9 men to choose from, right? So again, we have to follow the same scenario over here. So if I have Different cases over here, obviously, if Albert has been selected. So that means I have two possible choices. I can have four more men to be selected and one women more to be selected, because I need five men, one woman, or I need three more men and two women to be selected. And mind it that the total pool has been reduced. So if I need four men from nine men now, so 9C4, Albert has been gone. Albert has already been selected, so it's nine men. Tracy cannot be selected, so that means we are selecting from the rest of the eight women now. Similarly, I need to select from nine women, nine men, three men, and from eight women, two. Okay. Now, before we actually solve this, we need to go with Tracy also. So Tracy, that means if the Tracy is selected, 1, 2, 3, 4, 5, we have a similar scenario. So one woman is already selected, so that means I need to select four men now. I can have, five men, zero women, or I can have four men and one more woman to be selected. So out of now nine men again, I need to select five men, and out of eight women, zero women to be selected. Similarly, out of nine men, I need to select four men, and out of eight, I need to select one more woman. Now I can calculate them all. So 9C4 times by 8C1. This is equal to 1008. So 8C2 and 9C3. I have 2352. Okay. And then I have 8C0, 9C5, 126, and 9C4 and 8C1, 1008. Okay, so if Albert is on the team, let's calculate. So 1008 plus 2352, 3360. And if Tracy is on the team, I have 126 plus 1008. I have 1134. So total possibilities are 1134 plus 3360. 4,494. Okay, all right. The committee that is chosen consists of four men and two women. They queue up randomly in a line for refreshments. Find the probability that the women are not next to each other in the queue. Right, okay. Now this is an arrangement case over here. So the committee that it's chosen, right? So out of 10 men, 4 have been selected, right? And similarly, we have out of 9 women, we have 2 women. So that is already chosen, right? And we are just arranging them in a certain way that the women are not next to each other in a queue, right? So we have 4 men, 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 men. The places for the women are restricted to these 1, 2, 3, and 4. So 4 factorial for the men because we have 4 men over here. And for the women, the places, one more. So places that the women can occupy are 1, 2, 3, 4, 5. 5 possible slots or 5 possible places, but only for 2 women. So we get 4 factorial times by 5 P2. We get 480. Okay. Another way we could think about this is 4 factorial for the men. Since we have 2 women, for the first women, we have 5 choices. For the second women, how many choices do we have? Not 5, but 4 places over here. So if I times 5 times by 420, we will get the same. Now this is the number of arrangements where this happens, right? So we need the probability of this, right? We will divide it by simply 6 factorial because we are just talking about the probability over here. 6 factorial means all the possible arrangements. So 480 divided by 6 factorial, that is 2 by 3. And that is your answer. Okay, so moving on to the 6th 3 October November 10. Okay, so let's make some space for this. So October November 2010 6 3. Okay, so a small airplane has 14 seats for passengers. The seats are arranged in 4 rows of 3 seats and a back row of 2 seats. Okay, 12 passengers board the aeroplane. Okay, how many possible seating arrangements are there for 12 passengers? So we have 14 seats, but only 12 passengers need to be allocated. So that's just going to be 14p12. So 14p12. So we need to give our answer correct to 3 significant figures. So this is going to be equal to 4.36 10 raised to power 10. Yeah. These 12 passengers consist of 2 married couples, Mr. and Mrs. Lane, Mr. and Mrs. Brown, 5 students, and 3 business people. Okay. The 3 business people sit in the front row. So that means these are the business people. So business people. 5 students each sit at a window seat. That means 1, 2, 3, 4, 5, 6, 7. Okay. So this is the students. Okay. And then Mr. and Mrs. Lane sit in the same row on the same side of the aisle. Mr. and Mrs. Brown sit in another row on the same side of the aisle. Right, so basically means that in these 3 pairs, basically, we have Mr. and Mrs. Lane, Mr. and Mrs. Brown. So basically, any of these 3 pairs of the window seats can be selected, but the other one, but the third one, which is not going to be with the married couple, that will have one of the students. Okay. Right. Okay. So how do we arrange them? For the business students, it's easy, 3 factorial. We just have 3 seats, right? Now, 5 students will occupy 5 seats. So 5p5, or just simply 5 factorial, right? And then we have out of how many window seats, one, two, sorry, how many of these do we have? So we have three possible choices, or three possible places where we can seat those married couples. So 3p2, because we have two couples, three possible places, and their internal rotations will also be counted, because the wives can wives and the husbands can, their places can interchange also. So uh, let's multiply them together. So 3 factorial times by 5 factorial times by 3p2 times by 4. So 17,280. Okay. If instead of 12 passengers, if instead the 12 passengers are seated randomly, find the probability that Mrs. Lin sits directly behind a student and Mrs. Brown sits in the front row. Okay, now this is for this we have to think a little bit. So Mrs. Brown sits in the first row. This means that Mrs. Brown could be in any one of these uh, things, any one of these front row seats. So for the Mrs. Brown, we have three possible selections, right? Now Mrs. Lin sits directly behind the student, right? Okay. So this means that wherever the student sits, Mrs. Lin will sit directly behind. Now, for the Mrs. Lin, now let's say for example, Mrs. Brown sits in this seat over here. So this means that the student cannot sit over here. So that means the student will either be over here, if we're talking about the front row seats, will be over here or over here. So that means Mrs. Lin cannot be sitting over here. So that means the second row, in the second row, Mrs. Lin can only have two seats, two possible seats, but the rest of them are open to her. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 possible seats for Mrs. Lin and one person, obviously. There is no condition on the four students. There's only condition on one student. So it's just basically at least one of the students has to be in front of Mrs. Lin. So 5p1. So if, for example, this is Mrs. Lin, so for example, if this is Mrs. Lin, then the student could be in front. But the rest of the students have no issue with them. Now, what about the rest of the people left? How many have we selected? We have selected Mrs. Brown, Mrs. Lin, one of the students. So 3 have been selected. That means how many people are left? 9 people are left. And that means 11 seats are left. So we need to seat 9 people in any of the 11 seats. So 11p9. Okay, so these are the number of arrangements in which Mrs. Lin sits directly behind the student, Mrs. Brown sits in the first row, right? And we divide this by, since we are asked the find the probability, right? And since this is 12 passengers, right? So this is going to be 14p12 because we had 14 seats but only 12 people. So okay, so we have 3 times by 10p1 times by 5p1 times by 11p9 divided by 14p12. Sorry, p12. We get this value, 364. So this is your answer.